So, this question here, we've already got the tree, and you're never going to be given where it says T, 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 H, H, T, and H, H, but they've given it for. So if they don't, make sure you write that one. Okay. The question says, the first question says, what is the probability of getting two heads? So out of my four, which one has two heads? It's only going to be that fourth one, right? So that's the only one I have to work out for part A. So that's 0.5 times 0.5, which is equal to 0.25. Okay. So the answer for part A is 0.25. Moving on to part B, the probability of getting a head and then a tail, that's specifically asking about the third outcome. The third one is literally just 0.5 times 0.5. So that one times by that one. Wait, hold on, let me show you properly. That one times by that one. So 0.5 times 0.5 as well, which is equal to 0.25. Okay. But this is what I was basically talking about. This is what the question is more likely to be. So this question says, what is the probability of getting at least one head? So I can have TT as a tail and a tail. Does it have at least one head?
No.
A tail and a head?
Yeah.
A head and a tail?
Yeah.
A head and a head?
Yeah.
So this one's 0.5. That's also 0.25 because I do 0.5 to 0.5. This question's a bit dead because every number is 0.5. But the point, the part C is the bit where you need to be confident. Just circle the ones that are relevant to the question or the statement and just add them up now. So we've done all the timesing, but now for part C, we just do TH plus HT plus HH, which is all of those things added up. There's one other way to do it. You see the one with the cross? I can also just do one minus that one. Yeah, I can do one minus the one with the cross, and I get the same answer. Question two. So because we're going to be testing all of them, I could work out the things on the right first, but in a real question, let's just see what we need to work out into as we go along. The probability of both boys missing, so that means miss and miss, so it's only going to be that outcome that matters for part A. The answer for that is 0.4 times 0.3, which equals 0.12. Part B, the probability of one boy scoring. So score, that has two boys scoring, so it's not that one. Score and miss, where Matt scores and Thomas misses, that counts. Miss and score, and miss does not count. So we have to work out both of them. So score and miss is 0.6 times 0.3 plus, and then miss and score is 0.4 times 0.7. I can also write them on the side, 0.6 times 0.3, 0.4 times 0.7, but I don't need to do that. Now I can add them up. So 0.18 plus 0.28, and that gets you 0.46. Yeah, did you get that?
Yeah.
Cool. And then for part C, at least one boy missing. So score and score does not count because no one missed. These other three all count. So I'll do it the quick way. It's just going to be 1 minus where they both score, which is 1 minus 0.42, which is 0.58. So yeah, like you were saying, we can use the information here to fill in the numbers of the period table. 0.8, so that has to be 0.2. That's 0.3. Wait, no, fading is 0.3. So her passing is 0.7 because I have to add up to 1. Um, and also just be familiar with how the table looks because you might have to draw it from scratch as well. Um, both passing is just this P, which is 0.8 times 0.7, which is 0.56. For part C, the probability of Megan failing and Rosie passing is specifically this third one here, which is 0.2 times 0.7. 0.2 is the chance of Megan failing, and 0.7 is the chance of Rosie passing. So that's 0.14. Yeah. And then at least one of them passing. The quick way to do it, so we got pass, 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 fail, fail, pass, and fail, fail. So which one does not suit that statement?
Fair, fair.
Yeah. So we just do 1 minus fail, fail, probability of fail, fail. The probability of fail, fail is 0.2 times 0.3. So that's 0.06, which is 0.94.